Hi. All right. So here's a video lesson about the triangle properties of today. There are three different things I got to talk about. First one has to do with the properties of isosceles triangles. So isosceles triangles, the definition of them is that two sides are congruent. So that's what makes it isosceles is two of them are congruent and one is different. That's really what makes it isosceles. And isosceles triangles, if there are two congruent sides, means they're two congruent angles. If you have these are congruent angles, like notice these are both 72 because these are both the same length. And the other one's 36 because all three of these have to add up to 180. This right here would be an example of a isosceles right triangle, meaning it's right like 90, two opposing sides are equal, and that means this is 45. Okay, so here are questions with that knowledge. Okay, so I'm gonna show how to do a few of these. All right, so this is 44, and it says angle 2 is x plus 51. Well, okay, so notice that the angle that's different is the one where those two congruent sides meet. Like this A here is not the congruent one. It's the two sides that kind of the two angles that are on the opposite sides of the congruent angles are the ones that are really equal. So this, in terms of number one, this angle down here is the one that's not equal. But this is saying angle 2 is 44. Okay, so this is saying angle 2 is 44. So number one is just x plus 51 equals 44. Okay, and then you would subtract 51 from both sides. X is negative 7. And that'd be the answer for number one. All right, now for number two, it would be, okay, so angle 2, if you notice that one, oh, it's an equilateral one. This is equilateral. Who the heck did that? All right, I didn't do that one, but this is equilateral, so this would just be like 11x minus 6 equals 60. I just noticed that. This is equilateral triangle, so they're all equal 60, so that means 11x minus 6 is 60, solve for x. Okay, so I'm going to do 3, and then I'm going to stop doing questions about this for you. All right, so angle 3, so next question 3, angle 2 is 8x plus 2. This is this. Okay, so this is 48. So I know a lot of you make it like 8x plus 2 equals 48, but that would not be true. Instead, we got to find out what actually is angle 2. Well, 180 minus 48 is 132. And what that is these two other angles would add up to 132. And according to the rules of isosceles triangles, where angle 2 is and this angle up here would be equal. So therefore, 132 divided by 2 is 66. So that means angle 2 is 66 degrees. Like this is 66, and this is 48. And so that'd be 8x plus 2 equals 66. And then you subtract 2 divided by 8, x is 8. Okay, so that's kind of how you do all these. That's how you do that. All right, that's one thing. All right, here's the next one. Exterior angle theorem. What is that? Okay, so exterior angle theorem is an exterior angle is formed by the sides of a triangle. I'm not really sure what this even means. All right, let's ignore the blanks here. I don't really want to talk about it. Instead, let's just kind of focus on this diagram here. Okay, so angle 4, this 4 is exterior to the triangle. Like the 1, 2, and 3 are the triangle, and this angle 4 is in the exterior of the triangle because this ray actually extends beyond the triangle. And well, angle 4 and angle 1 would be supplementary. They would be supplementary. But also what that means is since angle 1's here, angle 2 and 3 would add up to angle 4 because since 1 and 4 are supplementary, meaning they add up to 180, but also angle 1 plus angle 2 plus angle 3 equals 180. Therefore, really in this sense, you'd call it like angle, can't really do angle symbols, like angle 2, I mean, it's a 2, and the angle 3 would add up to angle 4. I know I'm trying to say angle 2 plus angle 3 would add up to angle 4. That's really what happens here. And say, notice it says that here too. And with that knowledge, you're able to solve a lot of variety of types of problems. For example, if I were to do, I'm going to do these two examples. All right, so looks like I got to solve for x. Okay, Angle B is 2x plus 10. Angle A is 3x. This is 120. All right, so now the C is supplementary to the 120, and the C, if I combine that with A and B, are 180. So what that means is the 2x plus 10 plus the 3x actually equals 120. It does. So the two opposite interior angles of the triangle equal the exterior angle of the outside of the triangle. And now you'd combine like terms. 5x plus 10 equals 120. And that means 5x is 110. And then x is 22. And if x is 22, well, we know that angle C is 60 because it's supplementary to 120. And if x is 22, that means angle A would be 3 times 22, 66. And I'm pretty sure that would make that one 54. Yeah. So for B would be 2 times 22 plus 10. And that's 54. All right. And that's how you do that. Okay, as for this example here, okay, so this exterior angle of 3x minus 10 would equal the angles that are not B. So the B one is supplementary, so this equals what the other ones are. So that'd be the 25 plus the x plus the 15. Okay, and y'all are so dang smart. I hope I don't have to explain how to solve for x with this. Yeah. So I'm pretty sure off the top of my head, x turns into 25. Yeah. Yeah. So x is 25, which is interesting. So that means this one, the B, or whatever this would be 65, and that would be 40, basically. Okay, so that's the exterior angle theorem. And then finally, well, yeah, do all these. Try all these, try these, try those 4. All right, now let's bring in the next thing. The next thing is the congruent triangle postulates. Okay, so next class is, we gotta do proofs. Yeah, there's proofs. And we have to do some proofs about triangles. And today I gotta kind of explain some postulates that you're gonna see, and you're gonna get tested on about whether just by visually identifying them. Okay, so I have a hard time kind of doing this via Desmos, but all right, I'm going to show you that there's these 4 things: SSS, SAS, ASA, AAS, and this is called HL. What these are 5 ways to identify that 2 triangles are congruent without really having all the information. Like this diagram here shows all the information. Like we have all the angles, all the sides. They're all congruent to each other, so you don't, that's it. So this is like the most information you get. These theorems are really kind of the minimum of what you need to do it. Let's see, probably the best way I can explain this is with, I get out. All right, so I'm gonna show you, all right, well, here's how I recommend doing this. Come on. Oh my God, what is this going on? Whoa, okay. I'm learning how to use the video making machine. Okay, so I'm going to go to Google Images. I'm going to type in SSS, ASA, SAS, AAS, HL. That's a good looking one. That's not very helpful. I don't want to pay you. Okay, let's find another good one. Okay, so SSS is when all you have the information. So the diagram I would draw here is this diagram. So you have 2 triangles, and what they have is their corresponding sides are congruent. And with that information, that is enough information to say that both triangles are fully congruent. Like if you say that, yeah, 3 sides of that. All right, SAS, that is the next one, means side angle side, meaning these 2 sides and the angle in between them are congruent in both triangles, that is enough information to say that the entire triangles are also congruent. What I'm trying to say is, like, all right, if the sides are all the same, that means the angles are the same. Even like they don't tell you the angles are the same, this is enough information to say that the angles are also the same. SAS is, okay, I have this angle, this side, and this angle. That's enough for me to say that every other part of the triangle is congruent to every other part of this triangle too. So that's a side with an angle and a side. ASA stands for angle side angle, meaning I have an angle, I have a side in between them, and then I have another angle. If that's true for both triangles, that is enough information to say that the two triangles are congruent. The weirder one is this one called AAS. That means angle side. Notice that it's not about the side in between them. It's about one angle that's kind of, it's about one side that's adjacent to one of the angles. This is enough information to say that the two triangles are congruent, meaning you just from having this type of diagram, that's enough information to say this is congruent to this, and so on. And the final one, the HL one, only works if we're talking about right triangles. So if I know that, so if you're given a right triangle and you're given that two of the sides are congruent, that's enough information to say the third side is congruent because of Pythagorean theorem. And that also is enough information to say the angles are congruent because of, well, trigonometry. So the HL one only applies to possibly right triangles. All right, so the rest of today is about, can you quickly identify are they congruent and why? So let me show you how I would do, come on, no. Okay, so I'm going to demonstrate how to do this one. All right, number one is actually not necessarily, yeah, this is not necessarily congruent because it does share an angle. It has an angle, it has an S, and it has an S. So notice our options are SSS, ASA, SAS, AAS, and HL. There are other abbreviations, but these are the only ones that really work to create congruence. Number one is A, because if that's 90, the opposite side is 90. A. It shares this middle line, which means that's congruent. That's S. And then they say that's that. Now notice none of these say ASS. None of them do. So this is actually no. It's a no. Like, we actually don't have enough information to say that number one is congruent. Not true. All right, number two, it's saying that this is congruent to that, this is congruent to that, this is congruent to that, but and they also share this. So for number two, that's SSS. That is enough information to say that those two triangles are congruent to each other. I want to do a couple more. Number three, this is a side, this is an angle, and notice they have a vertical angle, which means they actually have congruent angles here. So what this is, what number three is we got the vertical angle here, we got these congruent angles here, and we got a congruent side. So number three is an example of AAS. So that is congruence. That is congruence. It is. Let's see. I want to do one more. I'll do number four. Okay, so for number four, notice that we have, it says this angle and this angle, and they share these, no, well, actually these two are congruent, and they share a side. So for number four, that it's a shared side, there's an angle that's congruent in the middle, and there's a side. So number four is SAS. Okay, so that's how you do that. That's how all this works. I hope that was helpful. Have a good day.